The two questions presented here are taken from the Sine Rule worksheet on Corbettmaths, the Apply section. They involve using the Sine Rule, which is presented here, but also involve bearings. And the thing to remember with bearings is that angles are always measured from north in a clockwise direction and go from one place to another place. And the second of the questions actually does involve knowledge of the sine curve and the fact that different angles can have the same value of sine. We will see that when we come to the second question. So question 3 here, we have a little triangle and we have 3 places denoted by C, D and E. And we're going to add on to our diagram here. It says Donhampton's 48 kilometers from Castleton, that's already written on a bearing of 050 degrees. So this is Donhampton from Castleton. So we draw north at Castleton. Norths always go up. The angle goes clockwise, and that angle is 50 degrees. The bearing is 050. In terms of angles, we can just write 50 degrees. Eastville is on a bearing of 075 degrees from Castleton. So let's mark that one on. So going back from our north at Castleton to the line that goes to Eastville, that's 75 degrees. And it also tells us that the Castleton is on a bearing of 150 from Donhampton. So let's put a north onto Donhampton, and we mark on this angle as 150 degrees. Now hopefully you can see straight away we can put on another angle onto our diagram, because the difference between these two angles down here will be 25, and that's going to be useful for our triangle for our work. So that angle there is 25 degrees. You've identified one angle within our triangle already, and we are trying to find the distance of Eastville from Castleton. So we're trying to find this distance, which I'm going to call x. So this distance is going along here. We have two distances. We have 48 kilometers. We have x, which we're trying to find. We have one angle here. We are going to need another angle, because for the sine rule you need 3 of 4 things. So there's another angle we can put on. If we look at this angle here, that angle there, that is a co-interior angle with 50 degrees. If we look at these, the norths are always parallel. So if you remember your parallel line rules, this angle here will add up with this angle here to make 180. They're co-interior. So that angle will be 180 minus 50, which is 130 degrees. So if you need to remember that, go back and have a look again at the work on parallel lines. So we have 2 angles here on a complete turn, so we can put in the missing angle here. We have 130, 180 makes 280, we want to make 360. So this angle here is going to be 80 degrees. Okay, so let's have a look at this again. What have we got? We've got this triangle here. We have a matching pair of angle and side we want to know. We have a side here and an angle there, but they're not matching. They're not opposite each other. So I need this angle here. I can work that out because I've got a triangle. I've got 25 and 80 there. Angles will make up 180, so that missing angle will be 75 degrees. And now I have my 2 pairs that I need, 48 and 75 degrees, x and 80 degrees. So now I can move to my sine rule. So I'm going to write x over sine 80 equals 48 over sine 75. So that's this pair here and this pair here. Now I have one equation with one unknown, so I can rearrange and solve. So x will be equal to 48 sine 80 divided by the sine of 75. And if you put all that into a calculator, you will get the answer of 48.938, and that's kilometers. So the things to remember with a question like this, if it's bearings, put on the norths, check where you're going from and to, put on all the angles you know and all the angles you can derive. Then focus on the triangle. Do you have matching pairs? Because you need matching pairs to actually solve the problem, so you may need to work out another angle within the triangle. Once you've got that, use your sine rule and solve the question. In question 8, this one here, it says 2 ships A and B leave a port at midday. So we're going to need to do a diagram for this, do a little sketch. So I'm going to put my port over here. I'm going to put a north because of this bearing question. And the first bearing is 085 degrees, so it's 85 degrees, so it's just less than 90. So A is going to be, ship A is going to travel somewhere like that. The angle here will be 85 degrees. And we know it's traveling at a speed of 18 kilometers per hour. Okay, ship B travels on the bearing 113, so that's more than 90, so it's going down here. It says it's traveling slower, so it's not going to go as far as A, so I'm going to leave B there. I'm going to write my bearing on. My bearing this time is 113, so that angle is 113. And I'm going to go straight away and put this little angle on here because I think that's probably going to be important. 113 take away 85, that angle is 28 degrees. And the distance of, or between A and B is 30 kilometers. And this is at 2 o'clock, which is 2 hours after starting. So time is 2 o'clock. The journey started at midday. So they've been traveling for 2 hours. And we don't know the speed of y, and we don't know the distance it's traveled. So we just put the speed of y, of b rather, is y kilometers per hour. And that's what we're trying to find out. So we've been traveling for 2 hours. We know that speed is distance over time. So therefore we know that distance is equal to speed multiplied by time. And we need the distances for our triangle. So distance A is the speed of the first boat, which is 18, multiplied by the time, which is 2 hours. So that's 36 kilometers. So boat A has traveled 36 kilometers. And that's nice. We have one of our distances. Distance for boat B, it's traveled at y kilometers an hour for 2 hours. So the distance is 2y kilometers. So this distance down here is 2y kilometers. Okay, so what else do we know? Well, I know I've got one matching pair of angle and side. I've got 28 degrees and 30 kilometers, so that's handy. If I knew this angle up here at A, it would match with my 2y, and then I would be able to use my sine rule. So I've really got to try and work out what this angle is here. I don't know this angle here, but if I did know this angle here with 28, then I could calculate this angle, then I could use my sine rule. So I'm going to focus on this angle here, angle B. And that matches with this 36 kilometers. So that looks promising. So let's try that out. So I'm going to work out angle B here. And I'm going to say that 36 over sine B, using my sine rule, is equal to 30 over sine of 28. So that's using the matching pair here and the matching pair here. And that's, just to highlight, that's for this triangle here. So if I rearrange this, I'm going to get 36 sine of 28 equals 30 sine B. B is obviously what I'm trying to find. Sine B is equal to 36 sine 28 over 30. B is the inverse sine, so sine to the minus 1 of 36 sine 28 over 30. Now I'll put it into the calculator and I'll get the answer of 34.3 degrees. So that's the angle here I have at B, 34.3 degrees. But stop. Let's check the question. It told me very clearly that boat B was travelling at a slower speed than A. That means this distance must be less than this distance, which means the sketch is kind of correct, because this angle here is going to be obtuse. It's going to be bigger than 90. But I've worked it out to be 34.3. That would give me an angle, if I redid my sketch, my angle is going to come down here somewhere. Well, clearly that's not right. So we have a problem. Now, what you need to be aware of is the fact that the graph of sine is cyclical, and there are multiple angles that give the same result of sine. So if we look at the graph of sine, the sine curve works like this, and we can see here that sine of if our angle is 34.3 degrees, it's going to be about here, but that gives the same value of sine as an angle about here and an angle about here, and so on. So sine of 34.3 is going to be about here on my graph. That will give me a value of 0.56. You can check that on your calculator. But we can see clearly that also 0.56 appears here, and that would be this angle here. Now, what is that angle there? Well, the graph is symmetrical, so this distance is 34.3, this distance here is 34.3, so my angle will be 180 minus 34.3, which is 145.7. Now you can check it on the calculator. If you do the sine of 145.7, you also get 0.56. It's the same. So using that bit of knowledge, going back to my graph, I'm going to replace my angle of 34.3 with 145.7 degrees. Now that changes everything, because that makes sense. It's an obtuse angle, so that means my distance between the port and B is going to be shorter than the distance between port and A. And now I know my missing angle up here. My missing angle up here now will be 6.3 degrees. I do 145.7 plus 28, take that away from 180. I get 6.3 degrees. I now have my final matching pair, this pair here, going with my original pair I will use. So it's time to use the sine rule again, and I'm going to form this. So I'm going to have 2y over sine of 6.3, and that is equal to 30 over sine 28. So that's this pair and this pair. One equation, one unknown, so I can just rearrange. So 2y equals 30 sine 6.3 over sine 28. Y is then equal to 30 sine 6.3 over 2 sine 28. Put that into a calculator and I will get the answer of 3.5 kilometers per hour, which is clearly slower than the first boat. It's actually quite a lot slower than the first boat. Well, that kind of makes sense because this angle, if you think about 145, it's going to be here. It's going to be a big angle. So yeah, it's going to be predominantly a shorter distance traveled.